Alright, this is 5.2, specifically example 5-21. This is part 2 to the other 5.2 video. Alright, so in the example it reads, 1,000 tickets are sold at $1 each for a color TV valued at $350. What is the expected value? In other words, calculate the mean of the gain if you purchase the ticket. I'm going to make this into a probability distribution. In order to have a probability distribution, I need two things. The first thing I need is, what are the different outcomes? Now, my outcomes are of the gain. So if you win, you get the value, $350, minus the dollar you spent. So winning, I get a value of $349. Now, if I don't win, I'm out the $1 I spent. So that's the outcomes, that's my random variable x for the gain. Now I need the probability of each of those events, the relative frequency. So the probability of a win is 1 in 1,000. The probability of a loss is 999 in 1,000. So how do I figure out the mean when I have this? Well, I'm going to store it to L1 and L2 and let the calculator do it. I could multiply 349 times 1,000 and add it to -1 times 999 divided by 1,000. But I'm going to let the calculator do the work for me because I want to get used to using the calculator to do this for us. Now, other games of chance don't always have a win and a lose. There could be the win the grand prize, win the medium prize, win third prize, etc. But the same idea is attached to it. You're making a probability distribution. To be a probability distribution, you need two things: outcomes and the likelihood for each of those outcomes. I'm going to store those to L1 and L2, and then I'm just going to use 1 var statistics L1 comma L2. Let it do the work for me, and then the mean is going to equal my expected value, which is abbreviated E of x, for my set.